Good afternoon, everyone. Today we're going to continue our discussion on machine learning using fact the target variable as a factor, which means this is a classification problem. Our next machine learning lesson will be where your target variable is quantitative. Okay, so what have we learned so far? What we have done is to use the cardio dataset, split it into two. You have your training dataset and testing dataset. We use two methods of creating the partition. We have the sample function and we have the create data partition coming from the caret package. And we learned that the caret package with the create data partition is more powerful than the sample function from base R because you're able to preserve the proportion of the levels or the classes in your dependent variable. So what we did last time, we said that we have to we have to split our data into two, training and testing. For others, they split it into three, training, testing, and validation. Uh, and we said that we create the model, okay, using the training data set, and then we test the model using the testing data set and see if the level of accuracy in the use of the model for the testing data set is as accurate or as good as the one in the trained data set. If it's comparatively equal, then that's good. Otherwise, class, if it's not, then that means that our model is not is maybe it's already overfitted for the trained data set. Okay, so if you recall, class, we have had four models already. The multinom, which is the regular regression model, and then the first machine learning model was our decision tree using the party package, and we created three models out of that. Okay, and then we saw different results. So it depends on how you you control class your model. Okay, so for today we're going to use another package called rpart. Two packages in fact class, rpart and rpart.plot. So make sure that this is loaded. Check your packages class. If not, check your packages and check if these two packages are loaded. If not, kindly do so now. I'll give you a few seconds to do that. Okay. And once you're done, class. Okay, sorry. So it's 350, 340. Once you're done, kindly please chat in the chat box. Kindly respond in the chat box so that I know if I can already begin the discussion. Okay, good. Thank you. Okay, as usual, class, I said I appreciate your quick responses. Okay, very good. Thank you so much. Okay, for the others, I hope you're able to follow. Okay, if you have any questions, please feel free to call my attention, raise your hand, or chat in the chat box, class, or unmute yourself. Okay, all right. So I have loaded this, so I will not load it again. So for this one, class, I'm not going to share this with you. I want you to write it. So notice that we're creating this model 3 underscore rpart, and we're using the function rpart. This is from your rpart package. And same thing, NSPF regressed on associated with LB, AC, and FM data is equal to train. So I'm sure you know this by heart already because we've been using this for the past sessions. And then we'll print class the result. And we'll see here that the rpart package provides a better visualization of the result. Okay, so I'll run this class. Okay, and when you have run it, please again, could you please in the chat box class tell me if you were able to run this? And you can see here a result that's quite similar to what we have experienced in the party package. Okay, so this is our part. there are some a bit of differences, but it's practically the same. Practically the same class. All right. So once you have this class, kindly chat, please. The text representation class of the model. So here denotes the terminal model. So model number 2 here is terminal. All the ones with asterisk are terminal model. Okay, and we said that we will not depend on that. We would rather have a visualization of the output. So here comes the r rpart.plot. So this is another package that's related to rpart. Okay, so let's plot the object 3rpart. Okay, let's run this, control enter. And you can see that it's a lot better, it's cleaner than the party package. The party package class, not so good output class. This is visually class cleaner, a lot easier to understand. Okay, and once again, class, kindly chat in the chat box. Please, your response if you were able to generate the rpart.plot of our model. Our model is called 3rpart. I'd like to know with your, okay, thank you. Okay, good. Waiting for the others, please. All right. Okay, thank you. Okay, so let's see. Okay, and it's easy to explain this class. It's easy to understand the plot. Okay, you can see here in the first node here. Let me see if I can increase the size here. Okay, the first node here, class, is a decision node. And we're told here is AC, if AC is greater than or equal to 0.0017. If it's yes, then we go here. You have a decision immediately. If it's not, class, then you have to go to LB, the second variable. If LB is greater than or less than 137, if it's a yes, then you go here. You go to FM. If FM is less than 0.12, then you go here. This is a terminal node. Okay, you have 1, 2, 3, 4, 5, 6, 7 terminal nodes. As compared to the party package where we had 12 or 13 terminal nodes. Now, it doesn't mean that if there are more nodes than that, it doesn't mean that it's more correct or it's more accurate. We'll see, class, this is 7 terminal nodes compared to the nodes in the party package. Okay, so this is very easy to understand, very simple, and the graphic representation is really very easy to understand. Now, if you take a look at this one, class, this is 49% of your data. Our training data set has, if you recall, 1701 observations. And the probabilities here are 0.97, 0.01, 0.01. Therefore, for this decision node 1, class, the prediction here is n, normal, because the probability of it being normal is 97%. Okay, so this one has an all here, the 49% of 1701, so that would mean around 850 class, di ba? Kasi 49% ng 1701, mga 850 yun eh. Okay, so ang prediction nila dito is n. Here, class, it's also n kasi 72%. And it accounts for 28% of the data. Here, the prediction is S. NPS, 77% yung S class. But it's only 1% of your data. Here, another N class, 64%, and it accounts for 9%. Here, another N class, 71 dito, and yung probability, 1%. Here, another S to, no? S. Sorry, class, P pala to P, P. This is 0.7, NSP. This is P, this is S, and again, this is also S. So if you add the percentages, class, 49, plus 28, that's 77, no? 77 plus how many here? Okay, plus 9, so that's 86, 87, okay, 87, and then 87, no? Okay, 87% yung N class, yung prediction natin ng N of the total 1701. So, of course, it's not all correct, class, kasi based on the proportion of the table, we know that 78% of the observations that we have are N. But if we add here the percentage of the total observations in our trained data set, it adds up to around 88%. So that means mga 10% kagad dun mali, no? Okay. So, any questions about this plot, class? Is it very easy to understand? Chat box again, class. Respond please to that question. Very self uh, very self-explanatory, class, yung model, di ba? Tsaka malinis yung yung ano natin, yung I don't know yung label nito, no? Ba't kaya nakaganito? 1, 2, 3. Okay. So, yung mga 1 dito, here, parang hindi naman tama yung ano. 2 is, here the gray is number 2 daw. And then the green is 3 here. Yun. The green is class level 3. 1, 1, 1. Okay, I have to check, class, kung ano yung color coding dito. No? I don't understand what the color coding is. Except for the fact that ito 1, okay? Tapos lahat ng grade 2. Yan, number 2 nga, no? And then lahat ng wala yung wala yung 1 din sila, no? Ito. Okay, anyway, what's important is this one, class. Okay, so let's continue. I'm going to close this. Oops, okay. Now we can also have different types of plots here. So I'm going to share this code, okay, in the interest of time. Anyway, pareho naman yung code na yan. We just added extra, okay? Extra is equal to 1, 2, 3, 4. Control C. Kindly copy this, yung code na to. Control V. Okay, and let's see what's the difference. So if we have extra is equal to 1, it means that it will include the sample sizes. Kasi dito, class, instead of sample sizes, ang nakalagay yung di ba? Ang nakalagay yung percentage. Okay? Ang nakalagay, class, yung percentage niya and the total percent of the population of the trained data set. So let's run this, include sample sizes, okay? Control Enter. And you can see now the plot is a bit different. Okay, tingnan nyo, class, ito. Here for decision node 1, it's 18, 8, 17, 11, 11. That is consistent with this one. No? Okay. And this is 817, class, is N. Okay. 817 out of 11, out of 829. No? And 839. 22, yeah. So here, all that went here to this node, 839 observations, all were predicted as N. So here, mali yung 22, di ba? Kasi yung 11 dito, it belongs to S. Yung 11 dito, it belongs to P. But they're going to be predicted as N. Why N, class? Because the probability, class, okay, of it being N is 97%. All right, and so on and so forth, class. No? So we can see here the distribution. Here, number 3 is that's your P, no? Pathologic. Okay, so etc. class, you have here the sample distribution. Okay, then we can create this number 2, and this belongs to the proportion that belongs to a group. Control Enter. You can see here the percentages. Okay. Here, 817 out of, I mentioned this a while ago, 839. So we have 817 out of 839 as the correct prediction. Okay. For the others, this is 341 out of 474 correct predictions, 88 out of 154, 75 out of 132. So you can see here that there are wrong predictions. No? Okay, and number 3 shows the proportion that doesn't belong to the group. For example, here, 817 over 839. Therefore, this should be 22. 22 do not belong actually here. They're being predicted as n, but they're not actually n. Okay, so number 3 is, okay, 22 out of 839. So it's the proportion of the wrong predictions, class. And number 4 class is the same as this one. Okay, this is number 4. So try running number 4 and comparing it with this one, class, and you get the same answer. Okay, same diagram, same plot. All right, I'll wait for you, class, to confirm if extra is equal to number 4 is just the same as not mentioning extra. Please respond. Yeah, thank you. Thank you, Aiden. So let's wait for the others. Kindly confirm, class, if the extra is equal to 4 is just the same as not putting any here extra. Okay. Let's wait for the others. All right. So I hope you have convinced yourself that the rpart package gives a better visualization than the party package. Okay. But let's see. Actually, you can still modify this, but we will not go into the modification. Okay, I'll just leave you, class, to research on how, because this is the default model, class. And you can modify this. This is the default, class. You can modify this by taking a look at the syntax and try to figure out or research on how the model can be modified. Okay, so here, class, as usual, what are we going to do? The usual method that we're doing is here. Okay, let me just so here we're creating this object, the prediction of the trained data set. Again, the powerful predict function. Okay, what is the model? 3rpart class. And we have to identify, class, type is equal to class, because there's another type. Okay, and that can be, class, the probability. Okay, so we don't want the probability to appear. Okay, why don't we want that? Because we're going to compare it to our trained data set. Okay, di ba ang trained data set natin 1 2 3 1 2 3 1 2 3, di ba? It's reflected as the classes 1 2 3. So we want, class, the type of the prediction to be class and not probability. All right? And then let's now compare this object that we're going to create, first 20 observations, with the actual data set, train and SPF, 20 also. Okay, I guess I'll just have to copy and share this in the interest of time, class, because you know this already, class. So I'm not hesitating to share this with you. We have been exposed to this one, class, so many times here. Okay? It's a bit different lang yung ano class yung syntax ng predict for and the object here, which is 3rpart. By the way, class, I'm sorry, I forgot to check this with you. Let's take a look at the 3rpart. What object is that? Because in the party package class, what we saw is that it's a large binary tree. Here, 3rpart class is okay, where's that object here? 3rpart, here class. So it's a list. Unlike class, yung 3 mod 1 natin, large binary tree siya, no? So ito, iba class, no? Yung rpart object natin, model natin, it's a list. As compared to yung from the party package, you have a large binary tree. For the rpart class, rpart package, it's a it's a list. And there are some similarities and of course differences between these two objects. Okay, but let's move on. And let me just close this. All right. So I shared this with you, class. Let's print this. Okay, so this is our predicted, okay, predicted values. These are our predicted values, 1, 1, 1, 1, 1, 1, 2, etc. These are our actual values, 1, 3, 3, 3, 3, 2, 2. So offhand, immediately you can see that there are errors, no? There are misclassifications. So what do? We check, class, the accuracy of our model. And we'd like to see if this compares with your party package. Okay, so you might have good visualization for your rpart, but if the accuracy of the model is inferior compared to the party package, then of course we would better choose the party package. At least for this instance, I'm not generalizing. Okay, for this particular instance, for this particular data, it's better to make use of the party package if the accuracy is inferior. Okay, all right. So this is our manual class, manual to, no? This is not the caret manual confusion matrix for the trained data set. We'd like to see, class. All right, so for this one also, I'll just copy this because this one you know already. We've been doing this for many times, class. Okay, so remember we created this object, pred rpart train. So we can now create a table. Let's call it tab rpart train. The function is table. And then on the rows are your predicted values. Predicted is equal to, so it's coming from this one, the one that we just predicted. And of course, compared with your actual. Your actual is your train, $NSPF. Then we print this, okay? And then once again, we know that the correct predictions are the diagonals. Okay, so you know this drill, class. And then the percentage correct is just the sum of the diagonals divided by the total. And then the percentage wrong is simply 1 minus this one. Okay, all right, so we can run this. And we see that okay, for this one, class, for this data set, the rpart seems to perform better. Kasi when we did this in the train data set for using party package, I think the highest was 81.5, or yeah, I think 81.5. But for this one, it's 82.6. So higher, class. So if we compare the models, okay, using the train data set, then rpart performs better than the multinom, class, the regression model using GLM. It performed better than the model 1, model 2, model 3 of the party package. Okay, 82.6. I don't think we got something higher than this. But the acid test class is to compare the if the model will work with the testing data set. Because this result class is the result for the data that was used to model, okay, to model the classification, okay. But let's see class, okay, this one, you know this, okay. I'm going to use this, okay. All right, so just copy class this one. Sorry. Okay, let me share this one. Okay, although I did not share this in the other section. Okay, all right. Take note, class, that here we're not anymore creating this one. We're not creating a predict object, just like this one. Predict rpart test. No, we're not creating that. We're going straight to creating the confusion matrix manually. So we're creating this tab rpart test table, and then the predicted value is we're going to use the function class here. Predict using the three-part model, the type is equal to class. Okay, take note of that because I think the default is the probability. Okay, so if you use that class, you'll not be able to generate there will be an error because you're comparing one column, okay, of the test data set. And then here, if it's probability, then it will be three columns because it will be the probability of the classes. Okay, why don't we check that class? Okay, I'm going to go here. Uh, this is, asan yan? So very sensitive, this one. Okay, will that be under predict? Let's say C class, and we have to check the predict. Okay, so let's see if it will give us the type. Taking some time. You see here. Sa ano to eh, SJ plot to eh. So, may type ba dito? I don't think so. I think it's a predict of another. This is SJ plot, so it has a different. Walang type dito, no? Okay, so it's not the predict of. If I'm not able to see it, class, then yan, ito sa stats siya, sa stats. So predict examples. Additional arguments. Okay. So GLM, ito, predict.lm, let's see. Predict. If there's nothing here, then let's just leave it as that class. I like to see the type class. Wala rin, it's not here. Type, where's the type here? Okay, it's not here. Here, class, here. Here, type. Where's that type? Where's that type? Nakita ko na siya kanina. Iba dito, no? Response or terms. Okay, dito class yung type natin is okay, class, no? Let's see if I make this as response. Response. Okay. Control Enter class. Error, hindi siya, no? Ayaw niya. Wait. Kasi yung result natin, okay. Hindi ko lang maaalala class yung ano. Okay, I think this is correct. Predict rpart test. Predict rpart test. As in predict rpart test. Here class. Tingnan yung class, no? Yan, no? 425 observations, 1, 1, 2, 3, no? Okay? And then, tingnan yung class, it's probabilities. Okay, if I click this one, so there are 3 columns. Just wanted to point this out, class. Take a look. Yan, class. So, probabilities, ito ba? Ito. So, we cannot use this class kasi we're comparing it with the train dollar and SPF. Diba? Isang column lang yon. Ito, 3 column. So, that's what I wanted to point out, that make sure that here, dapat dito class, hindi probability, but class. So, let me rerun this. Okay. All right. So this one class, this one, we did not create this object. Hindi. Saan yun? Here. Saan na yun? Here class, no? We did not create yung pred rpart and then test. We used directly the formula here. So the predicted is equal to, this is your row, this is your predicted using the model 3 rpart. Type is equal to class, and then new data is equal to test data set. Compare that with the actual test data set, dollar and SPF. So let's check class the confusion matrix here. Okay, you can see class 82.11. So this is higher than the other models that we created, higher than the multinomial, higher than the party, model 1, model 2, model 3. Remember we created 3 different models. So the rpart package was able to provide better results, better prediction. Okay. Now, of course, class, the best one is your confusion matrix class. Okay. Ito class here. Here. The caret package class. Okay. Confusion matrix. Then we have to identify here what is our predicted value, comma, what is our actual value. So the predicted value here is, we use the predict function, the same that we use above, 3 rpart, type is equal to class, new data is equal to test, and then compared with data is equal to test data. So the advantage of using the confusion matrix is that it gives us other information. So I'll run this. and it gives us the confusion matrix from the caret package, which is a lot better than just manually. Okay, nagsabi dito, thank you Moises predict that rpart. Okay, I'm sorry, yeah, hindi ko yata tinignan to, no? Yeah, thank you so much Moises. So sabi ni Moises, no, it's predict that rpart. Kasi I just used predict lang no? So what I should have done was, tingnan natin rpart, rpart, rpart package, rpartition, rpart here. Okay. Here you have predict. Meron ditong here class, predict that rpart. Okay. So technically class, I should have used predict that rpart. But tinanggap niya yung predict, no? So mas maganda yung predict that rpart. Okay, and we check this class. So type is equal to ito class of vector probability matrix. Okay, thank you Moises for that, for pointing that out. Maybe we should change this, no? So to make it clearer, mas maganda class kung ito gamitin natin here. Predict that rpart. Okay? So if we change it, it will accommodate now. Although hindi natin linagay class, we did not put that rpart, no? So R was able to see that we were actually looking at ito kasi class, no? rpart to This is rpart. So nag-default siya na maintindihan niya, no? But we can put this class as a, say, more complete function. Okay, thank you Moises again, no? All right, so where are we now? Okay, so this tells us class that the rpart package was able to produce class a better model compared to the others. However, class, in terms of accuracy, okay, you have 82.12% for the test data set, but we could have just used the no information. What does no information class mean? Since there are, how many number ones are there? There are, okay, let's check. Just to be sure and to be precise. How many levels, how many class ones are there do we have in the test data set class? We can use a table function, table, and then test $NSPF. So you have how many number ones, how many number two? 331. So this is it class here. Here. 331. So actual 331 all in all. Okay. So we could have just used this class 331. Just predict everything as n. Okay, so our error will be just 331 divided by okay, 320. Of course, I could have just use the proportion, no? 320 plus 11. Sorry, the total class. Okay, the sum of our, what's our table class here? Okay. Ano ba to? 77? Ano ba ang ginamit ko class? Wait. 320. What was I answering class? No NIR, no? No information, no information rate. Where's my NIR here? So NIR is 88.94. So how many are the ones? No? How many are the number ones? This is wrong class, sorry. 330, bakit 331 to? No? Wait, sorry class. Table of test and SPF. The predicted one is 331. Okay, but the actual number of number one is 320 plus 32 plus 26, that's 58. So that's 378. Okay, so 378 divided by 425, the actual. Okay, that's 88.94. So, sorry, once again, class, how many number ones are there? This is the actual, 320, 32, and 26, so that's 378. Okay, so if we're going to use n as our prediction class, we will be correct 378 times out of the total 425. So you have 88.94% accuracy for that. As compared to using the model, using the rpart, you'll only have 82%. And check the p-value class. We're saying here that they're the same. The accuracy, the accuracy using the model and accuracy using NIR are just the same. And the p-value is practically approximately 1 class. So that's really very high. It's greater than 0.05. So we fail. Okay, so again, the null hypothesis here is that the accuracy is better than the baliktad, no? Dito ako nako-confuse lagi, class. NIR, bali class, it would have been parang same lang class, no? Walang effort, walang class, walang advantage ang coming up with this model, yung rpart natin. Okay, and we fail to reject that class, no? Okay, walang advantage class yung using yung accuracy kasi yung mas mataas pa nga yung NIR natin eh. Okay, which means better pa yung NIR. Okay, so that's for the that's for the test data set kasi maliit na lang yung test data set natin class, no? And malaki yung number ng ng ano natin ng ng number one natin class. Okay, sorry. Okay, so I leave you class to once again try to study class yung mamunta tayo sa FFT. Try to study class yung ano nito, yung meaning nito, yung sensitivity, we discussed this, specificity. Actually, lahat ng mga meanings ito class nasa confusion matrix. Okay? So, understand the confusion matrix. There are many references class which tell us how to compute for sensitivity, specificity, positive predicted value. That's very, very easy to find out class. Okay? And then also the others. Okay, so let's leave that class and take a look at decision tree using FF3s. Okay, now, yung FF3s class, that's another package. However, the caveat here is that it only supports binary dependent variable. So what do we do? Because our NSPF is trinomial, di ba? Tatlo yun, N, S, at saka P. So what do we do now? Okay, what we do now is we can convert class our data into two levels, two classes. So I think it's practical to just combine your S and P into not normal. Okay, S is suspect, P is pathologic. So we can merge the data into S, which is not normal, and P also, which is not normal. So I'll load first the FF3's class. Okay, and then when you have loaded it, please write in the chat box. And Control C. I'll share the code with you once you once you respond class in the chat box that you have loaded the FF3's package. Okay, good. Thank you. All right. So I'll share the code now. Control V. Oops, sobra siya. Okay, again, two parts na lang. Control X. Di pa rin. Control V. Control Z. Okay, I'll make it up to number 5. Control X. Okay na. Okay. All right. I'm really more confident now sharing the code with you because I know that even if you're meeting the code for the first time, you'll be able to understand it as we discuss. Okay. So the first one, class, is we're going to recode our NSPF. Kasi, di ba, we have NSP, 3 levels siya. So if it's trinomial class, we cannot choose FF3s there. And the objective is for us to see the FF3's package. FF3's FF class stand for fast and frugal. So it's a very quick way class to generate decision trees. But you're constrained to only 2 levels. So what we're going to do is we're going to create a new variable class, NSPF binary factor. So we're going to use the factor, or the same as that factor, and then we have a conditional statement here, if else. No? So if cardio NSPF is equal to 1, so let's review class our cardio. Okay, our NSPF class is, let me view cardio. Our NSPF is 1, 2, and 3, right here. NSPF 2, 1, 1, okay, 3. So what we're going to do is that 2 is suspect, right? 1 is normal and 3 is pathologic. So we're going to combine, don't worry about this, you don't have it yet, class. We're going to combine class 2 and 3 and make it not normal. So we'll change the nomenclature. So here is, if NSPF is equal to 1, then make it normal. Otherwise, make it not normal. Okay? Normal, not normal. And then our levels will be C, not normal, and normal, which means that we're converting it into a factor. It's not a character variable. Okay? So using levels mean that this becomes a factor. So let's run this class. And let's also include, let's see, okay, let's include structure of cardio. Mamaya na class. Sige, sama na natin. Cardio. Okay, so let's run this. Control Enter. And then if you check the cardio dataset class, if you check the cardio dataset, we now have, okay, we now have another variable, NSPF. Okay, here class, NSPF binary factor. Okay, and we said that if it's not equal to 1, then it should be named as not normal. If it's equal to 1, then normal. So you can see here that 3 is not normal. Okay, and this variable is a factor. Why? Because we nominated class, we included the levels here. So if we check the structure of cardio, let's just double check class. Here. Okay, you can see here that NSPF and NSPF binary factor is also factor. Okay, with 2 levels. The first one is not normal. The second is normal. Okay, let me pause for a while, class, and again, request your feedback if you're able to follow so far. Waiting for your chat, class. Good, thank you. All right. Appreciate class your feedback. Okay, I keep on saying this again and again because I'd like to really encourage you to give me feedback if you're able to follow. All right. Thank you so much, class. Let's give your classmates a few more seconds. Okay, good. Okay. Now let's go to the second, number two. Let's partition. And we're not going to use the sample class, the sample function, because we have proven that the create data partition is more powerful because it's able to preserve the proportion of your variable of interest class. Here, we're creating a data partition for this one class. Based on this one, probability is 80%, okay? And we would like to make it not a list class, but a vector. So here, class, we're creating this object train index, okay, FFT, because the index is based on this on our train data set. Okay, let's first create an index. So it's from the cardio data set. Our cardio data set has 20, how many observations? Cardio 21, 26 class. So it will now create a vector consisting of 21,026 numbers. Okay, and then we're going to split it. Okay, here we're going to create train FFT and test FFT using the index class. Okay, so all the numbers, sorry, all the 80% of the numbers will go to the train. Okay, this will generate, by the way, 80% only, not 21, 26, because we're saying only 80%. So everything, the 80%, the 1701 numbers will go to train, and those that are not in the 80% will go uh, to the test class, test data set. Okay, so make sure that we run this also class in set.seed so that we have the same values. Okay, all right. So set.seed 1, 2, 3, 4. Let's take a look at the train index FFT. Train index FFT, you have only 1701. Okay, because we said that create 80% class. No? So the train index FFT has these observations. Okay, 1, 3, 5, 6, 7, 8, 10, etc. It's quite different from the train index which we originally used. Okay, but same thing, 1701 observations. Okay, so the numbers here, class 3, 5, 6, 7, we're going to create this partition data train FFT, and we're going to use the cardio data set to train to get the observations 3, 5, 6, etc., etc. And the rest, minus train index, the ones that are not in the train index, will go to the test data set. So quickly checking train FFT, I already ran that. Here, class. Train FFT, 1701 observations. Okay, let's see. Train FFT. You can see that the first observation is number 3. It should be number 3 class there. Number 3, 4, I think 3, 4, 5. Here class 3, 5, 6, 7, 8. Okay, so the ones that are not part of what will go to the test data set is 1, 2, and then 4, etc. Okay, so you know this class because we have discussed this before. Okay, so let's now go to the third one. Okay, so this is just similar class to, okay, we can actually here we can just subset class because train FFT we're going to subset. We're going to use all the rows, but all the columns. We'll just choose the 4 variables that we need. Okay, LB, AC, FM, and NSPF binary. Okay, this is also helpful because it 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 cuts our object into the the and splits it or subsets the only ones that we're going to use in our model. Okay, so we're creating this. This is a vector, and then train FFT class will be. Remember, our train FFT is already a vector class with 24 variables, and then we'll just limit it to 4 variables. Okay, we're going to all the rows and then only include those objects, those variables that are present here. Okay, same thing with the test data set, test FFT, and then only include those columns that are LB, AC, FM. Okay, so let's run this. And your train FFT now. Okay, so the train FFT has now been changed, no? It's now still 1701 observations, but 4 variables. Okay. So we chose only those that we'll be using in the model, LB, AC, FM, and the non-NSPF binary. Okay, let me pause for a while and ask class for your feedback, if you're following so far. Okay, I didn't see. Okay, good, thank you. All right, so thank you so much, class, for your feedback. Okay, so we have run this, okay? We now have this train and test data set that are that only contain 4 variables. Okay, if you get the structure of this, we can see that the last, which is NSPF binary factor, is a factor. We've seen this actually previously. Okay, now let's convert class our NSPF binary. Okay, now let's create an object called NSPF binary. Okay, and for the train dataset, train SSPF, we will ask the question, is NSPF binary factor is equal to not normal? So what will happen here is that if it's not normal, since we're testing a class, then it will answer true. If it's not normal, then it will answer false. So you're creating this object class, NSPF binary, which contains true or false. Okay, so let's run this. I gave this to you, class. Control Enter. So we're creating now a new variable, NSPF binary. In addition, we have the NSPF binary factor, right? So I'm going to print this train FFT class. Train FFT will now have 5 variables. So you have normal, then sabi natin, if it's not normal, then say we're asking if this data, if this observation is normal, then we answer. Kasi if it's equal to, so that's false, it's not equal to. So all the normals will have false, and all the not normals will have true. So we have created a binary object here, okay? Binary variable. So let's check class. Let's just check the structure here. Structure str of train FFT. Okay, let's take a look at the types of objects there are there, class, here. Diba? So LB, AC, FM, they're quantitative. NSPF binary factor is factor, and then NSPF binary is logical. So false, true. Okay, so this is now binary class, and we can now use this for our FFT, because we said that FFTs will only use, okay, binary class. All right, so let's go now to number 5 here. Okay, if we take a look at this, let's check first class, see FFT model natin. No? Let's run this first. FFT model using FF3s, open parentheses, the formula is we're using now the NSPF binary. So this is not a factor, this is logical, true or false. Okay, and then regressed on LBACFM, data is equal to our train FFT. Okay, and then just give the regression model a name FF3s for NSPF classification. Okay, if you run this class, control enter, let's see what the FFT model is. Okay, so let's check FFT model. What type of object is this class? Okay, nag-run pa lang pala. Okay, running, and it's a list class. Okay, you can see it's printing now. Okay, let's wait. It created an FF3's object. Okay, ranking 3 Qs, 100%. Okay, let's wait. All right, so checking class FFT model, it's a list of 8. If we check what's inside this one, FFT models, criterion name, formula, and then you have the trees here, no? You have the trees here, okay? Data, parameters, etc. Okay, so let's now check class. Let's now print. I'm going to close this first. Masyado na marami. Okay, going back here, class. Let's now print yung FFT model mismo. FFT model here. Where's that? No. Here, class, here. Let's print this one first, FFT model, control enter. Okay, and then it will print class a text output. Here. You can see here, this is a text output of your FFT. What did we name it? FF. Name na class? FFT model, okay? So if you take a look at this class, trees, fourth FFT, fast and frugal trees, predicting the NSPF binary. So you have here cost of outcomes, and then cost of Qs, LB, ACFM. And then what's the definition? So simple lang yung model niya, class. First check AC. Is AC greater than 0? Then decide false. Diba? So immediately not normal if AC is greater than 0. And then go here. Is LB greater than 132? If it's greater than 132, then what's true, class? True is, okay, sorry. If AC is greater than 0, then decide false. What's false, class? False, class, is normal. Diba? Yung not normal natin is, that's the one that's true. If LB is greater than 132, then decide that it's not normal. Okay, and if FM is greater than 0, then decide true. It's not normal. Otherwise, decide normal. So you only have this one, class. Very simple. Okay. And then we have here the confusion matrix. This is your true positive. Okay. True positive. And then this is your false positive. This is your true negative. And then this is your false negative. Okay. And then you have this H, I, M, I, F, A, and CR. So this means something, class. No? So the correct prediction is 276 plus 1074. Okay. Out of the total 1701. Accuracy, class, is 79.3% for a binary data like this. All right, and then there are several metrics here: ACC, BACC, okay, sensitivity. Okay, so I'd like you to hopefully you'll have time to at least study this. Okay, and then this one is a better. Let's plot class D model itself, plot FFT model, and you can see here that it generates a very beautiful plot. Okay, a very instructive plot class. Here class. Okay, so I'll let you first discover what are these class. Okay, here class. So may mga meaning to, no? Probability of false, probability of true. Okay, then you can see here, di ba? If AC is greater than 0, then ano sabi? Ang decision daw, tinan yung to class. This is the decision tree, no? Di ba dun sa nakita natin kanina dun sa pag-print ng FFT model? If is AC greater than 0, if it's greater than 0, false. Ano ibig sabihin ng false on class? Normal siya, no? Normal. And then you can find here the correct prediction and the wrong prediction. And then after this, you go to LB. Is LB greater than 132? Then it's true. What does that mean? True class means na not normal. No? Not normal. So 229 correct, 199 wrong. And lastly, is FM, ang sabi, greater than 0? If FM is greater than 0, then ang prediction natin siya, not normal siya. So 52 wrong, 47 correct. Okay, otherwise class, false. What's false? What's false? Normal siya. So 148 correct, 39 wrong. Okay, and then you have here the truth matrix or confusion matrix. No? These are correct. Okay, this is what we call the true positive. Okay, predict siya na true when actually true siya. That's called your TP, true positive. This is called your, this one class. What's this? Predict siya na false, pero true siya. Okay, so this is your false negative. Okay, so dito sa apat na to class, and true positive, true negative is this one. Predict siya na negative, okay, false, when in fact, false siya. Okay, so what's this class? This is your false positive. True positive, false negative, true negative. Okay, and then that will now have a bearing on the metrics class. And this one class, we're going to quickly discuss this, yung ROC, okay? That this is your rate, ano RRC class? Sa curve to no? ROC, okay, I'm sorry, I forgot the exact definition of ROC. We'll discuss it on Friday class. Then you have here the accuracy. All right, so this class is your FF trees, fast and frugal trees. We could not use it class for the cardio data set because the cardio data set is trinomial in levels or in class. So can we compare this model with the rpart or the party? No, class. Unfortunately, no. Okay, we cannot compare them because your target variable is different. For the past models that we were creating, the target variable was NSP. For this one, it's either normal or not normal. But I wanted to introduce this class because I wanted you to know that, of course, you can still use the party package and the rpart. It would be good for you to experiment on what if you have two levels, two classes. Then we could have compared class the multinomial also, but that will become binomial class. And then also the rpart and the party package and compared to the FF3s. Okay. All right. Were you able to get this class? For the details class, I would that you do a deeper study on that. Okay. Were you able to follow along, class? Quick, quick comment lang, class. Okay, good. Thank you. All right. By the way, we haven't run this, no? All right. So take a look at this, class. We are able to run already number 5. Then let's do number 6. Same thing, class. FFT pred. We predict, class, using the FFT model, and then the new data is the test. We're going to now. We're not going to get the confusion matrix for the trained data set. Actually, it's already here, class, diba? Sa FFT model, because FFT model used the trained data set. So we're just going to look at the accuracy here, by the way, class, is how many? How much? 79%. Okay, 79%, diba, class? You can check it out here in the FFT model or in the here, class. Here, accuracy, class, 79.3. Okay, 79.3%. So let's see if this will work good with the testing data set here. So we're creating this object FFT-pred. We can actually, if you want, you can put here test just to make sure. New data set is equal to this one. All right, then FFT-pred, we're creating this class. You have to put here test. Okay. All right, what are we doing here? In preparation for the confusion matrix class, we're creating this object FFT pred factor. Okay, and this is now for the test, because what we created this only for the trained data set. So same thing, factor if else. If FFT pred test data class is not normal, dalawa lang siya, no? Not normal and normal, and then levels will be not normal, normal. Okay, and then the reference factor will be if else, not normal. Okay, so I hope you're not confused with this one, class. Okay, here we're creating another object, FFT predict factor, and then here we're creating another object, ref factor. Okay, so if you run this, let's just run the whole thing, class, 6, 7, 8, and then print your CM confusion matrix. I hope I was able to change properly kasi pinalitan ko to, no? Yeah, it run. Okay, here, class. So, wow, there are our test data set, class, run as good as in our training data set. So for our FF3s, we were able to run our, it's almost time, class. I'll just end in this, no? Okay, and this is our confusion matrix. So again, I'd like to encourage you to check this. All right, so this is, okay, let me just share this. Control C, just this last one. Control V. Okay, did it fit? Okay, fit. Okay, and then I'd like you to take a look at this class. Kasi ito, class, diba? We're creating this logit model. We first create the model, and then we create the predicted value, and then we create the confusion matrix. Also here for the party package class, we create the model, we create the predicted value, and then we create the the confusion matrix, all making use of the test class. For the prediction and the confusion matrix, we're now doing this for the test data set. In creating the model, we're using the train. In creating the prediction and the confusion matrix, we're using the test data set. So for the 3 models class, multinomial logistic, decision tree, and the decision tree using the party, and then decision tree using the rpart, And then we compare class, logit regression accuracy. Okay, so we're just getting from the confusion matrix object yung overall accuracy. Okay, so we're getting the overall accuracy of each of the models. Okay, so if I run this, everything here, class, then it will now have we will now have a comparison of which gave us the best model class in predicting the test data set. So nag-converge siya, ibig sabihin may solution. So let's just wait for it, and then after this, we'll call it a day. All right, the printout here, class, logit regression accuracy 82.35. Okay, decision tree 80.7, and decision tree rpart 82.11. So it turns out that as far as our data is concerned, the multinomial regression class fared best among these three options. Okay, so in the next meetings class, okay, we're going to compare now. Okay, compare natin class si random forest. We will include random forest. We will include SVM and also XGBoost. Mahaba yung random forest, no? I'll simplify that. XGBoost and ANN. Okay, so all in all, we'll have 6 models and 7 K nearest neighbor. We're going to include that because K nearest neighbor is also good for categorical variables, for classification. Okay, so let me, may I have class a comment